This lesson is going to work through solving exponential function word problems where we're being asked to solve the base that is either the growth rate or the decay rate. Okay, so let's first start with an example that is asking us to solve a growth rate. It describes a colony of bacteria is being monitored in a petri dish in a laboratory. When the experiment started, there were 35 bacteria present, so the initial value. 14 days later, there's our time period, 750 bacteria were present in the dish. What is the growth rate of the bacteria? Okay, so we'll set up our equation and we will substitute in the values that are described in the problem. The final amount that was observed is 750 bacteria were in the dish. Initially, the initial amount, there were 35. The B value, the base, is the unknown, and we know that they were monitored for 14 days, so that's the number of growth periods. We will express our answer in a growth rate per day. Okay? All right, well, the first thing we're going to do is we're going to get this variable b all by itself on the one side. So I'm going to take 750 and divide it by 35, and that equals b to the exponent 14. Okay, well, then I can just take the 14th root of both sides. So 750 over 35, we'll take the entire root of that, and that will be b. And if I do that, I am left with the value that b is equal to 1.2447. Okay, so that is the base, and we have to be careful here because we were asked for the growth rate. All right, well, this base, it is a growth base because the value is greater than 1. The question you have to ask yourself is how much greater than 1 is it? So it is actually 0.24, and I'm just going to round, 5 above 1. Okay? And that expressed as a percentage would be 24.5%. And that is the growth rate. And we will make sure that we add per day because we used an exponent that was expressed in days. If we had expressed that in terms of years, we would get a different base, and again, we'd have to express it as this many percent per year. Okay, so that's how you do it. The important thing to remember is when you're taking the roots that you're going to take the 14th root of this entire quotient. Make sure that is assessed first. And then secondly, make sure that once you get the base, you correctly extract the growth rate out of that base value. Okay, good. Let's take a look at an example that's going to work with decay. This next problem involves exponential decay, and we are again being asked to solve for the base, or in this case, the decay rate. Because we're talking about a car and the value of a car, instead of decay rate, it is referred to as the depreciation rate. Okay. A car is bought for $20,000, and then they're telling us in 7 years the car's worth is only $3,066.62. And it's asking us to find the annual rate of depreciation, that is, the annual decay rate of the car's value. Okay, well, just like before, we will go ahead and we will build an equation using the values that we were given. So the initial amount of the vehicle was $20,000. The current value, or the value down the road 7 years after that initial value, was actually less. So it was only $3,066.62. We are searching for the base, but we do know the number of depreciation periods. In fact, there were 7 years of depreciation. Okay, well, just like we did before, we will isolate the variable b. So I will just take $3,066.62. I will divide that by $20,000, and that will be equal to b raised to the exponent 7. Then I will take the 7th root of both sides. So that will be the 7th root of 3066.62 divided by 20,000. And I would encourage you to hold off on evaluating the quotient inside and do it as part of the 7th root so that you don't lose any decimal accuracy. And when we get that answer, that will be the value of b. Right? Well, the value of b, if we plug that into our calculator, will be 0.764999. Okay, well, let's just round that to 3 decimal places and make that 7.65. All right, so that is the value of the base. Now the question is that the depreciation rate? Is the depreciation rate 76.5%? And the answer is no, because what we have to ask ourselves is how much below 1 is it? Okay, so because growth rate is expressed as a percentage above 1, well, decay rate, or in this case the depreciation rate, is expressed as a percent under 1, that it's losing. So all we need to do is we need to take 1 and we're going to subtract 0.765, and that's going to give our answer, which is 23.5%, or 0.235. All right, so 23.5% is the annual depreciation rate. Okay, and we just need to be careful that when we do solve for the base and we realize that we've got a value of b equal to 0.765, that we don't stop there. We say, yes, that is the base, but that is not the decay rate. We have to ask, how much below 1 is it?